Welcome to the programming session of data structures. We have seen till now four types of linear data structures: arrays, linked list, stacks, and queues. While discussing the data structures, we have seen appropriate code while its operations are going on. Say, for example, insert, how it works. We have seen the code then and there itself. Linked list insertion, how a node is inserted in the first position, in the middle position, in the last position. So we have seen the working with respect to some example, and we are familiar with the code, how exactly the code can be written. But as a complete set of source code, we haven't presented it. So in the form of a program, I just want to demonstrate it over here to some data structures like a stack, singly linked list, doubly linked list, queue, and some of the applications of the stacks. Once we are done with this one, then we will move on to the non-linear data structure part. So today we will start with the stack data structure. This data structure you can implement it in any of the programming languages like C language, C++ language, Java language, anywhere. But here we will be seeing with respect to C language. Very small difference you will find in the implementation of C and C++. With respect to C++, we are going to use classes and we are going to create the objects with respect to the class, call the member functions. So let me just give you a brief introduction about what we are going to learn over here. See, the first thing is everything we are going to write it in the form of an abstract data type, ADT. Abstract data type just consists of the storage class, what exactly the memory is required for that particular data structure, along with the operations. What are the usual operations you carry out with that particular data structure? Say, for example, create a stack or allocate the memory for a stack using array, then insert the element, delete the element, find, search, is empty or not, is full or not, finding the number of elements, that is counting the number of elements, displaying the list of elements. All these operations will be carried out in the form of a ADT. You will be placing that one. So here, once you place the ADT, once you create the ADT, then come out of that particular class and implement individual functions. With respect to object-oriented concepts like C++ is a object-oriented programming language. What exactly it is? It is a object-oriented programming language. Whereas on the other hand, C language is a procedural language. C language does not support object-oriented concepts like creation of a class, data encapsulation, data abstraction, polymorphism, inheritance, templates. We don't have exception handling. These are the concepts which are supported by the object-oriented programming language. There are many object-oriented programming languages are there, like Java is also one of the object-oriented programming language. Here we will be using it, the basic programming language, that is C++. In this one, the features what we are going to have in C++, object-oriented concepts. First thing is, we are going to implement the stack data structure, or let it be array data structure or linked list data structure in the form of ADT first. So that means that we are going to create a ADT with respect to the member functions and data members, whatever we have identified. Then implement those particular member functions outside the class. This is one of the regular concepts what we will be following in all of the program, that you will find it common to all the programs. Coming into the next concept, what is included in this particular set of programs is templates. Templates is a generic data type, like we have discussed when we have seen starting from arrays only. I am telling you all these things, that if you create a structure and you are specifying the type over there, that type is a specific type. Only integer you can specify, only float you can specify. That means that you can't change the data type and substitute the value. Whereas at runtime, I want to decide that my class needs integer data. So what I'll do is at runtime I'll pass the parameter integer parameters. It will accommodate integer data. Similarly, if I feel that I want float data, so I'll pass the values, I'll pass from the main function from where object is created to the class, then it will accommodate that float data. Similarly, I can accommodate any type of data at runtime. That is something referred to be as a generic class. That generic class you call it as a template class. Templates are of basically two types: function template and class template. Here we are going to use it is class template basically. A template which is associated with the data member and member functions of a class is a class template, whereas a function template is a template which is associated only with a function, only one specific function. You create a template, then you call that one as a function template. Here the template what we are going to have a declaration is template is the keyword, followed by class is the keyword again. Then you have a user defined template type T. Some other features are also there, like exception handling you can accommodate in this particular one. If I will say, for example, we have a stack data structure. Whenever stack is full, say user tried to enter the value, some more values. If the size of the stack is 10, user is trying to enter some more elements, say 11th element. That cannot be accommodated. We give a message to the user saying that stack is full. Stack full condition is also called as stack overflow. Stack overflow. When this scenario occurs, you can raise an exception to the user. You can throw an object using exception handling in C++. Then you can catch that particular object and give an appropriate message to the user. Instead of program abruptly terminating, you give a message that stack is full or overflowing, then you terminate the program. Okay, that way also you can implement it. That feature also you can implement it. Here we are not implementing that object oriented concepts. Okay, that is try and catch concept of object oriented one we are not implementing. We are just using the first thing is template, we are declaring it over here. This means that this particular class stack is not a normal class, it's a template class. Whatever data it's going to contain over here is going to be a template data. Here you can just see the name of a template. It's a user defined name. You can use any other name instead of T. So I am using it as a template name T. No other variable I can use it with the same name called as T in the whole program. Okay, let us start with this one. Class ADT. Now it's starting from here. Class ADT, class consisting of stack. It's having two types of access specifiers. Actually, object-oriented programming languages like C++ provides three types of access specifiers. One is private, another one protected, another one is public. First one, public. Like here, we have public access specifier. Anything specified under public can be accessed from within the class, outside the class also. Any function can access that particular data, or any function can call that particular function. Then private, on the other hand, does not allow you to access the data outside the class in which it is declared. Say for example, this data, what we have over here, you can see after colon followed by this one, we have data like top is a integer variable, size is a integer variable. One array we have declared S, that is for stack, we have created it. It's a one-dimensional array. What type of array this one is? This array is going to store template type of data. So whenever I say star S, you can read this particular statement in two ways. Say it's a pointer variable. S is a pointer variable which can store the address of a template type T. Instead of T, if I substitute integer, then I can say it is S is a pointer variable which can store the address of a integer variable. On the other hand, even I can read this statement as S is a one-dimensional array. So what type of array this one is? It's not a static array. It's a dynamic array. It's a dynamic array. At runtime, you are going to allocate the memory. It's clear? So now let us see it one by one. So I was discussing regarding the access specifier. 3 access specifier I have mentioned. One is public, another one is private, another one is protected. 2 things we have already make it very clear. Public means can be accessed. Whatever declared under public can be accessed within the class, outside the class, from any other function. Publicly available, you can say, it's public. Private is a private copy of the class in which it is declared. So you cannot access it outside the class basically. So for example, there is a concept in object-oriented programming language, inheritance. One class derived from another class, code reusability whenever it comes. The existing code, we want to use it in some other class, then you use it, that one, in the form of code reusability, inheritance concept. When one class inherits from another class, say for example, class A is the base class, another class you are deriving it as a D class, derived class. So whatever class you are deriving it, say base class is having private data, derived class want to use that particular data. So I just want to make sure that the data is available only to the derived class, not to any other class. Then instead of declaring that one as private, I can even declare that one using protected. It is same as private data to other classes, public data, that is protected one, to the derived class. So protected use is you can use the data whatever you have declared in that one, whereas only base class data you can use it and derived class data can be used. Derived class can use the base class data, on the other hand, I can say. Coming it to only private and public, we are using it over here. Now what are the things we have over here to understand is, first thing, we are using a constructor. What is a constructor basically? A constructor is a special member function which need not be called, like you have to call other member functions. I have written many other member functions over here, like insert, delete, search, find. There are many other member functions are there. Why I am calling this one as a member function? Functions which are part of a class, functions which are part of a class are something referred to be as member functions of that particular class. What is the advantage of having a member function? Member functions can access the private data of that particular class. So the use of member function is, whenever a member function is declared, that member function can access the data member of that particular class. No other function outside the class can access the private data. So to access the private data, we will be having it the member function. It has to be a member of that particular class. It is something like this. I have a club. In that particular club, there are many resources are there. Say playing caroms, playing chess, you have swimming pool. There are many other resources are available in a specific club. As a third person, as I am not a member of that particular club, I want to access the resources. So I will be restricted. I may not be allowed to access those particular resources by the members of that particular club, saying that you are not a member of the club, isn't it? Like a country club is there. I want to access the resources. You can't access the resources of that particular club unless and until you become a member of that particular club. So here also, to access the data, here this is the important resources. This is the important resources of the class, what is there. Okay. So to access that particular data resources, I have to be a member of that particular class. So to be a member, I'll be declaring that one in the class ADT first of all. So this ADT is now going to have actually ADT does not have any implementation. But here I am showing you one implementation, saying that you can even implement the member functions within the class itself. Other things we will be implementing it outside the class. Fine. So these are the some of the points what I just want to mention it. That is, let me repeat the things where we have started it. The object oriented concepts what we are going to use it in this particular programs are, first one is a template, next one is abstract data type concept. That is, you are going to specify the ADT and its implementation is done outside the class. Okay. Then what are the other things you have regarding this one is, a class consists of what? A class usually consists of data members and member functions. What are data members are? Data members are private resources, important resources like an array. I am implementing a stack using an array. So for me, this one is an important resource. I am going to store the data in this particular array. So I don't want this array to be accessed by any other person. So I'll be declaring this one as a private access specifier. Private access specifier. Other than private, we have public access specifier, which says that you can access all these member functions or any other data if you have within the class or outside the class or from any other function from any other class, you can access it. That is public. Third one is protected, used only in the derived class when inheritance occurs. Protected, that one is the third one. Let us now take this particular concept, template one. I have declared a template where I am using templates over here. You can see templates over here is template declaration. I am using it over here. First time T, in place of declaring the data type, I am writing the name T. Instead of writing the data type over here, what is the syntax of writing S is equal, how to allocate the memory dynamically in C++? Allocating the memory dynamically in C++ is done using new operator. This is for one dimension array. At runtime, we are deciding what would be the size. At runtime means what? See, when we have something like this, let me come to the main function down. Here is, you can see main function. In this particular main function, actually in real-time applications, what happens is you keep ADT in a separate file. You provide implementation of those particular member functions in a separate file. And this particular part, that what you are seeing it currently, main function part, is something referred to be as application part. Application part is kept in a different file. Then ADT is kept in a different file. Then the member function specified in the ADT implementation is done in a separate file. That means there are three different files usually. I'll repeat it once again. There are, in real-time application, there are three different files in which you scatter the data, scatter the program basically, you can say. How do you place the data in three different files? First file consists of only class ADT. Then class ADT consisting of data members and member functions. That's all. No implementation. Second file consisting of the implementation of the member functions specified in the ADT. Third file is an application file which tries to access or call the member functions. This is your application file. What we are doing it over here, we are trying to access the member functions, like insert is one member function, display is another member function, delete is another member function. We have again find is another member function. Like that we are calling many member functions one by one. Okay. This is your application file. In your application file, the first step what you are going to specify is instantiation of object. What it is? Instantiation of object. What do you mean by instantiation of object? It is nothing but creating an object. Where you are creating the object, here is the line in which you are specifying that class name stack, which is not a normal class, it is a template class. There we have specified T. Now when we are creating the object, you specify what type of data that T should contain. I am passing the parameter as int. That means I am deciding that I want integer type of array to be created. There in class ADT and its implementation, we haven't specified anything. What data type I want in the array, what type of values I wanted in the array of what type I should create. No, I am not deciding at compilation time. I am deciding at runtime. What type of data I am going to accommodate, what type of array structure I am going to create it. This is where you specify int. The meaning for this particular syntax is, I am creating one object with a name called as s1 by passing 6 as a parameter. That means the array size should be 6. Sorry. I want the array size to be created as 6. Then where this 6 will be passed as a parameter? Whenever you are creating this object, automatically runtime environment calls or invoke constructor. Constructor, as I said, is a special member function of a class. Why you are calling that one as a special member function of a class? Because for other member functions like here, display, delete, we are explicitly calling it s1.display. Meaning for that one is object name dot member function name. s1.delete, s1.display, s1.find, like that you are calling it, explicit calling. Whereas for constructor there is no explicit calling. Constructor will be called automatically whenever object is created, like this here. This line specifies instantiation of object. Meaning for that one is creation of object. Creation of object invokes the member function called as constructor. In our class, we have only one constructor. What is that constructor is? Parameterized constructor. What would be other types of constructors? C++ provides. C++ provides basically different types of constructors, like first one is default constructor. Second one is a parameterized constructor. Okay. Then you can have copy constructor, a constructor which copies the object, one object into another object. We have different types of constructors are there. Here, this one invokes parameterized constructor. Your program starts from here actually. But you must have first of all that ADT class and its implementation of all member functions. Then only you can invoke it. How do you implement these particular things in real-time projects basically? Say, I have some project on stack to be implemented. Then application file you created with .cpp extension. This file, only this particular one is .cpp extension. But I have created all three in one here. In real-time project, what you will be doing is, from main function, you created this file as .cpp. Whatever ADT file you are creating it, whatever implementation file you are creating it, you name it with .h. Include that particular one in this application file using #include. #include, you are going to include that particular file in this application file. I hope this particular concept is clear. Let me have again, let us see the working, how exactly the working is, the control flow of control from main function to that particular class, how it is going to be. Whenever this code executes, first line executed, constructor is called. That means that control goes to here. Control goes to this particular line here. What I am highlighting it over here, control goes to this line. Actually, this line should have only the prototype, that is the definition part. Implementation should be outside the class. Implementation should be outside the class. But I am trying to show you that you can even have implementation within the class also. So once it comes, so from where the program execution starts, Program execution starts from main function. In main function, what is the first line of code to be executed? Instantiation of object. Once instantiation of object is done, what is invoked? Constructor is invoked. Which constructor we are having it over here? We are having a parameterized constructor, one type of constructor among the three what I have listed. So here, when the control comes into this particular constructor, whatever value we are passing it, what value we are passing it from there in the main function? 6. 6 value is copied into S1, SI. SI, size, small variable name I am using, SI, temporary variable. 6 is copied. Then you are assigning that value to size in this particular line, and you are initializing top to -1. You know that whenever you create a stack, the initial value for top is going to be -1. Indicates stack is empty. Currently there is no value available in the stack. That initialization part you are going to do it in constructor. So whenever object is created, automatically you are going to assign the value top to -1. Where from you are getting this top? This top is a data member what you have declared it here. No other member functions can access, no other functions can access, only member function can access this value. So constructor is basically used, the purpose of constructor is to initialize the data member. Second one is to allocate the memory at runtime. These are the two jobs of a constructor. I'll repeat once again. What is the job of a constructor is? The job of a constructor is to initialize the data member. What is the data member we have? Here there are two data members are there, top and size. Size of the array we don't know. At runtime we are deciding that it can be 6, it can be 10, it can be 60. That value you are passing it as a parameter, assigning it into size. This is initialization. This initialization can be done in a constructor. First job of a constructor is to initialize the data members. Second job of a constructor is to allocate the memory. What memory we have to allocate? We have to allocate the memory for a array. Here is the next line where you are seeing that S assigns new t. T, what is the value of t we have passed from main function? Integer. So here integer type of array of size 6 is created, and the base address of that one is stored in a variable called as S. I hope this concept is clear. Fine. Now we will move on to the next one. The next part in the class ADT is here. What is this particular type of function is? This function is again a special member function. I am calling constructor also a special member function. This time this one comes. Seems to be constructor only, but there is a small difference over here. What is this one over here? Symbol specified is tilde. Tilde symbol we are specifying it over here before the name of the function. This function is called as a destructor. Destructor, opposite to your constructor, deallocates the memory or uninitialize the values, release the resources whatever you have held in your program. So what is the memory, what is the resource we have held in the program currently? We are holding up the memory for an array. We have allocated the memory for the array. So what is our resource right now? Our resource is a one-dimensional array of size 6. That memory, whatever user has created, that is the job of a user to deallocate the memory. When it should be deallocated? I don't know when the program is going to terminate, isn't it? The program can be run for 5 times, 10 times, 100 times, storing the value, deleting the value, finding whatever operations you are doing it. Then when should I release the memory? I can release the memory in a destructor. Then comes a question. When destructor is called? Like a question is there. When constructor is called? Constructor need not be called. Constructor is called automatically whenever object is created. Right? Got the point? Destructor is called automatically when the program is about to terminate. When the program completes its execution, it's about to terminate, destructor is the last function to be called and execute its body. What we should do it in that particular one is release the memory, release the resources whatever we have, uninitialize the variable if at all you want, give any appropriate user to any message to the user you want, say we are terminating the program, bye bye, whatever it is. I'm just telling for fun purpose. It's not like that. So whatever memory we have allocated it, just deallocate that memory is the job of a destructor. Coming into the next part of a member function over here, concentrate on this particular syntax very clearly, as we have something specified over here. What is the name of this member function is? Name of the member function is this part only this one, insert. Insert is the name of a member function. What it is taking? It's taking one parameter. What type of parameter it is taking? Template type of parameter, because we are specified T only, that's all. We have specified only T. What this T is right now, we have decided in the main function that it should contain integer. Automatically when we call insert, it will substitute integer in place of T. Clear? Coming into the most important part of this particular function here. What is the return type of insert? What is the return type of insert? Return type of insert is a reference type of the same object. Reference type of the same object. What is the object we are working with? We are working with an object array. One object we are having in our hand is a one-dimensional array. That array is now modified by calling insert function. Say earlier there were no element in the array. Currently I am calling insert to insert one element. Has the array modified? Yes. The array has been modified by inserting one element. Now what I'll do is I'll just return the reference of the modified object. Return the reference of the modified object instead of returning the object itself. Are you getting? One more time I'll explain one. It's something like this. Say I have 10 elements in an array. I want to insert one element, one more element I want to insert it. So 11th element I have inserted it. So currently there were 10 elements. New insertion process has inserted one more element. I want to return this particular structure to the calling function. One way is to return the complete array, complete memory you return it. But the best way is you just return the reference of that particular memory structure. Using that reference you can access all the 11 elements. Easiest way. This particular facility is provided by your object-oriented concept of C++. Using the reference of the modified object I am saying. Modified object, the array. Earlier there were some elements, now some added elements has modified the data that is going to be array. So you are returning the reference of the modified structure. So insert, actually what is the syntax of a function? Whatever data type you specified before the name of the function will be the return type, isn't it? What is the return type? We are specifying it over here. There is no data type we are specifying. We are specifying the complete class name reference. Class name reference we are specifying. What is the class? Stack is a template class. Its reference I am returning it. Got that thing? So it's a modified object what is returned. Let me make it one more thing clear over here is whenever I am saying modified object, reference of a class, what is the significance? What is the common thing about these two things is class is same as an object? Is class is same as an object? No, class is not same as object. How do you understand the thing? You just see this one is a class ADT, you are seeing it here. Practically I am showing you where exactly the object is. Here is the object, this line S1. S1 is the name of the object. Object S1 is of what type? Is of stack type. Object S1 is of stack type. So what is the common thing, or what is the relationship between this class and object? Do you first create a class or do you first create an object? You first create a class, then you create the instance, that is the object. So you say an object is an instance of a class, like you have already learned in your C++, the definitions part basically. Object is an instance of a class, isn't it? This is one of the instance of a class stack. Class is just a blueprint, it's just a ADT part, right? It's just the member function, data members and member function. So when encapsulation you have learned, a class consists of data member and member function together, combined together, isn't it? Encapsulated basically. That encapsulation is done in a class. Once you create a class, create the object next, call the member functions from the class using this particular object. Coming back to our discussion where we have stopped. Here, I was telling you this particular part, it's a reference type of object. Whenever I say class name, I am referring it with the object. So interchangeably I will be using class name with object name. Okay. Next thing is here, next member function call. Every line having a different member function call. What is the name of this particular member function is delete. In C++, delete is the name of a operator also which releases the memory. But there is a significant difference between this delete and the delete which is used to release the memory. There is a small d available to delete the memory, like here you can see this delete. Delete with a small d is a operator which releases the memory, whereas this d is a user defined delete. This delete is a user defined delete function name it is. Now coming it to what parameter this one is taking. You can see what parameter it is taking. I'll just highlight only the part what I am interested in. This one, I am interested in this particular part. Can you compare the parameter of insert with the parameter of delete? Yes, there is a small difference. What is that small difference is? Ampersand. Whenever ampersand comes, it is a reference parameter. While discussing push, pop, insert, delete, I told you clearly one thing, that is reference parameter, pop, if you remember now. Why we require reference parameter? Whatever value delete is holding, that can be accessed from main function. So what value got deleted? Say for example, I have 3 elements, 10, 20, 30 in this stack. Topmost element is 10. I'll call a function delete or pop. So which element is getting deleted? I don't know. So I'll pass just a parameter, reference parameter. Then whatever value that is getting deleted is placed in that reference parameter. Then the calling function can access that value. Yes, 10 got deleted. Main function knows now. Main function now knows that 10 got deleted because of this particular reference parameter. In insert, we need not know. We know the value what we are inserting it. That's why there is no reference over there. We require reference in delete because what delete is doing, main function should know what value it is getting deleted. For that one, we have a reference parameter. Here, the next member function call is search. You know that the parameter for search is going to be the element itself, but we are not specifying element here. What is the type of element? Template type of element. It's a template type of element. What it returns? it returns the position of the element which is present in the stack. So stack contains 40 or not, I am trying to search. If 40 is available, I'll say 40 is available at so and so position. So what is the return type over here? Is the position is of type integer, either 4th position, 5th position. If it is unsuccessful, -1 will be the position. So the return type is integer. Then the next member function. We have clearly seen the difference between find and search. In find, we know the position. We know the position. We are trying to find the element. So here, given the position, element is returned. Given the element, position is returned. Exactly contrasting one. I know the element, I want to find where exactly it is available. I am calling that name, operation name is search. I know the position, 10th position, but I don't know who is sitting at 10th position, isn't it? So I'll go and find out who is there at 10th position. That element I am returning it. That is the return type over here, element. Similarly, the next member function in the list to be implemented is here, length. Integer length. Counting the number of element at any point of time, you want to know what is the number of element. You call length, it will return you the number of elements within it. Obviously, the display is going to print the elements of the stack. Since it doesn't return any value, void is the return type. And the last member function in the class ADT is top. At any instance, at any point of time, I want to know what is the topmost element in the stack. I'll call this function. It returns me the value, or it returns the position also. Where exactly you want to return, you can return it. You can return T also here. Element, topmost element, you can return it. This completes with semicolon, flower braces with semicolon over here. You can see the next line completes the class ADT. This completes the class ADT. You can copy down this ADT right now. I'll give you some time to copy down here ADT. Then we will proceed further for the implementation part. You can copy down this one. Two header files, I am including it over here as it requires input output operations, C in, C out, interaction of the user is required, C out, at least printing of data is required, IO stream is used. Conio, that is console input output. Anything regarding console input output, get ch function I am calling, CLR SCR function, clearing the screen function is calling. Then you require console monitor, keyboard, console input output, whatever input output operations we are doing it. So there are two header files required. You can copy down from this particular part. To give you some time to copy. I'll just scroll down over here if you have done with this. So till semicolon, that is till class ADT only you copied. The remaining part is not required. Okay, I hope you are done with this writing of class ADT. Here we are done with the class ADT. Good thing about the Turbo C++ editor is it will clearly make out what are the keywords, what are user defined words. Like here, you see class is a keyword, private, int, public, int, new, int, void, all these are keywords. Built-in words are clearly highlighted with a different color, and a user-defined keywords are highlighted with a different color. If there are certain errors are there, it will highlight it with some other color. That we will see it very soon, what exactly the errors are. If there are something missing, quotations, double quotation is missing or single quotation is missing for string type of data, then it will show you with a different color. Let us now come to the implementation part. I hope this concept of class ADT is clear. Let me just have a brief thing before going to have implementation part. First thing is a class ADT consisting of two parts. It's data members and member functions part. That is what exactly the storage part we required, how operations are going to be carried out. That is the functions part. Second one is this ADT can contain only the definition part of the functions. That is the member functions definition. Here are the member functions. But some functions can provide implementations like constructor. You can provide the implementation there itself. Here is the implementation part of the constructor. What I want to do, say for example, I don't want the implementation of constructor here. So what I'll do now is I'll remove this particular code from here. This complete code, I'll remove it from here. I'll place it outside the class, and I'll just need to specify what exactly its prototype is. I require this one. Just want to copy this part. It's control insert, okay. Here I want to place here just need to specify semicolon here. I need not specify the value, that is the type of parameter name. That's all. There is no implementation in the class at all. I have implemented it outside the class now, but this particular destructor should be implemented as a template one. So I need a template. So here is a template. You can copy down this particular one template from here and place it over here.